Hi all, this is Mr. Yeager for Physical Science. We are starting our unit on electricity, and therefore we start with the topic of electrostatics. What we're going to look at today is basically how do objects develop a charge. I know we talked about it back in chemical compounds where we gain and lose electrons. We're looking at this at more what's called a macroscopic level, where basically we now have objects we can see. How do these things form charge? It does relate to the electrons, but there's a couple different ways we can make that happen. So here we go. All right. So there's some terminology we need to know first. We're going to talk about something called electrostatics today. Yes, that sounds like static electricity. It is the same thing. Kind of the way to think about electrostatics is this is electricity at rest. Now, the electrons that are making up the electricity are still moving around the body, but it's basically where you are holding a charge. All right, that's why we kind of say it's at rest, is that you are holding this charge on that object. It's not allowed to move and conduct to another object. So that's electrostatics. Static means still. Okay? Electric charge, that's the property that will create a force between two objects. So we talked about that with positive repel, positive negative attract. So this creates the charge between the two. It is created by an imbalance of electrons and protons. Again, going back to our ionic compounds and things like that, this is where electrons are gained and lost, and we form positive and negative charges. All right. Then, as the prior definition basically says, when we have these electric charges, it creates an electric force. This is an attraction or repulsion between the two objects. This is what makes things actually repel and attract. Okay? So where does this electric charge come from? We've already talked about this, so this is kind of review. All right? Matter is anything that has mass and volume. We've already talked about that. And the matter we know is made up of atoms. Okay? The small particles called atoms. And in these atoms, we have the particles, protons, neutrons, and electrons. Protons being positive, electrons being negative, neutrons being neutral. Again, protons and neutrons are in the nucleus, and the electrons are moving around on the outside. All right? So they're getting their charge from their protons and electrons, but it's mainly the electrons, all right, that are moving between objects. They stay close to protons because they are attracted to the positive, but they are on the outside. They are what we can manipulate without changing what the substance is. So, with electric charge, this is why you have been shocked before, all right, or you've seen sparks. Anytime there's a spark or a shock occurs, that is due to an imbalance of electric charge, all right? One object must be positive, one object must be negative, or they're just at least different charges of negative and positive. All right? If an object gains or loses electrons, we become charged. Again, hopefully this is all review from our earlier units in chemistry. We know opposites attract, positive will attract negative, like charges repel, positive, negative. All right? So, when we have these charges, we can create a strong force between these objects, all right? And basically, again, it's the force that's creating the attraction or repulsion. As we've talked about before, I keep on saying before. As I said, I hope most of this is review, all right? Most matter is neutral. There is no charge. That's why you're not being pulled towards something because of its charge. All right. But if something does become charged, we can see this attraction and repulsion develop between those objects. All right. So here's just a silly little picture of that. Like charges. Sorry, on this I'm looking at the wrong one. Like charges repel. They'll push away from each other. Opposite charges attract. They come together. There are two we never create either charge alone. So when we went back and talked about, when we talked about how would sodium and chlorine react? Sodium has 1 valence electron, chlorine has 7 valence electrons. Okay. We know that the chlorine will come and take that electron. All right, it'll come over and grab that 1 electron, and then it'll have now 8 valence electrons, but that means it will be negatively charged now. It has 1 extra electron. The sodium, because it lost that electron, will become positive. And so what this first statement is saying is a sodium atom cannot become positive just by itself. If sodium loses that electron, it must go somewhere. It must go to something else, and therefore we never create charge alone. Charge is always created in pairs. This is related to something that basically we call the law of conservation of charge. Okay? It's related to the law of conservation of matter. We can't sit there and be like electrons are made or lost. Okay? Electrons are matter as well. They do have mass, they do have volume. Therefore, we can't just create or lose an electron. It must be going somewhere. So the overall charge must remain the same. We must cancel out this charge between the 2 objects, because if one becomes negative, one becomes positive, the overall charge is 0. Okay? This is something a little bit new. We haven't talked about anything with a field before. These atoms, these objects, not just atoms, but objects as well, to create this attractive repulsive force when they become charged, all right, they create what's called an electric field around them, an electric field. And what that means is the objects don't necessarily have to touch. These 2 objects are not in contact with each other. But there is an attraction between the 2 over a distance. And so with an electric field, all right, it will increase in strength when the objects are closer. If you've ever played with magnets before, that's a magnetic field, all right, where as long as you get them close enough, you'll see them all of a sudden attract. Same thing goes with electric fields, with charges. There's a video in this particular PowerPoint that I share with the students in class where you get to see the electric field some, all right? If you've ever messed around with a Van der Graaf machine, okay, that right there will show you the electric field. You can't necessarily see it, but you can see the effects that occur from it, all right? And we're seeing that all the time. We just might not really pay attention to it, all right? All right, so kind of reversing back again. We discussed how we create this charge. So now that we have this static electricity, okay, all right, and you can see all the little pictures here. This is again why your hair stands up and everything like that. It's an accumulation of charges. And what does accumulation mean? In case you don't know what accumulate, see, look at my lovely spelling here. I'm so good. Accumulation, okay. Accumulation, some people don't know the word. It just means basically you're gathering the charge. You're bringing it all together. When things accumulate, you're gaining more and more and more, basically. What happens is you get all like charges. What we're basically seeing in this dog's hair is this strand of hair is negative, this strand is negative, this strand is negative, the hair is negative, and what's happening is it's trying to repel itself, essentially. It's trying to spread out, okay? And so that's why Garfield's so mad down there too. So how do we create this static electricity? There's 3 ways. There's friction, there's conduction, and there's induction, right? With friction is where we're just simply rubbing those objects together. That's the one that you're probably used to most, okay? Where basically you just rub those electrons together. Yeah, rub those electrons. You rub those 2 objects together and you realize, hey, all of a sudden now it sticks, all right? With balloons, we see that all the time. All right, basically what's happening is some of the electrons are moving from one object to the other, and that means one side becomes negative, one side becomes positive, and we create this static electricity. That's why the 2 objects will stick together, but that's also why your hair will stick apart. All right, but key word there is the objects get rubbed together. All right, so there you go. Hair is positive, balloon is negative. I mean, we don't really know which one is which. The hair could be negative, the balloon becomes positive. It just, we know they form opposite charges. Conduction is where a charged object touches a neutral object. Okay? A charged object touches a neutral object so that we're not rubbing them together. We already have some object that is charged. How did it get charged? Who cares? Probably from friction or something, but who cares? All right? It's charged. What we can then do is if I touch that object to a neutral object, the neutral object will take on the same charge as the charged object. So what does that all mean if you're confused? We got this little animation here. Basically, this object comes in, it's charged negative, it sends a negative charge down to the other object. I can then pull that object away and the other object is still negative. If I come along and touch this, I'll actually get zapped. Why? Because those electrons are coming toward me and now my hand would become negative. So this is where you simply are touching one object to the next and transferring that charge to the other object. They all take on the same charge. Okay? Here's just another picture of it. This one always confuses people because this is where we have a positively charged object. What happens is the electrons move from the neutral object into the positively charged object. It's always the electrons that move, okay? Never the positive charge, all right? Positive doesn't move. That would mean protons move, and that would mean when that happens, we would see the object turn to something new, which would be cool in some ways, bad in other ways, all right? But it's the electrons that move. But you can see positive touches this neutral object. The object is now positive, all right? They basically take on the same charge. So friction is rubbing, conduction is touching. What about induction? Induction is where you charge the object without actually contacting it. So in my picture down here, what I have is this is a neutral object. I'm just going to write an N next to it. It's neutral. I bring up a charged object. What happens is that I don't touch it. There's space here. But it will repel all of the other charge basically to the other side. All right, it'll either repel the electrons or attract the electrons. In this case, since this is negative, it's repelling those electrons, and now this side is more positive. If I'm able to remove those electrons, my object will take on the opposite charge. So induction creates opposite charges on both objects, just like friction. Friction forms opposite charges, induction forms opposite charges, conduction forms same charge. So here's just another example. Basically, we have induction and conduction occurring. I hold something negative up. The negative charges run away. I can separate those two things out. Now I have a positive and a negative object here. Okay? But this is positive because the thing I held up is negative. All right? Same thing basically occurs down here. This I have induction occurring, but then I come along and touch it. That would be conduction, and then they take on the same charge. This would be conduction as well. Okay? So induction, no touch. Conduction, touching. All right? So what is other sources of this static shock or discharge? All right? Basically, when you get shocked when those electrons are moving from one object to another. Okay, that is called an electrical discharge. All right. This occurs when there's an imbalance of charge between the two objects. All right. The most extreme example of this is lightning. Okay, basically caused when the wind is essentially coming on by. The clouds basically rub together, and we're creating a very large imbalance of charge from the sky down to the earth. And then what happens is all of that charge wants to release, and it releases as lightning. Okay? So there's a release between clouds and ground. Lightning, as you know, can go any direction. All right? It doesn't, a lot of people think it comes from the clouds down. Some of the lightning comes from the ground up, depending on the situation that's occurring. All right? We know that there's heat lightning inside the clouds. In the summer, we see lightning happen in the sky. It never comes down to the ground. It's just there's so much heat up in the sky, those clouds are rubbing together, and they're creating lightning from cloud to cloud. All right? So this is just kind of a picture of how basically something forms. You don't have to worry about the whole idea of leader or the main stroke. All right? But again, this is just showing different neat pictures of lightning happening. Okay, so this is caused from an imbalance of charge. This is electrostatics at its most severe. And then here's actually somebody that got struck by lightning. There's their shoes, but the person actually wasn't killed. And that is it. All right. Thank you very much.